So now we are actually at the equivalence point, which means we've added the same amount of moles of strong acid as there was weak base. So there's no more strong acid, there's no more weak base, but what there is conjugate acid, in this case the ammonium ion. And so we'll have to use the concentration of the ammonium ion and the Ka for ammonium to find the pH. And the pH should be acidic because all we have is that the conjugate acid. So first off, I was like, writing out the chemical equation for what's happening so that with a BCA chart, because if we just say every single time we do one of these problems, it's BCA, then ICE, then it's just really one method that you need to remember. And we've already looked at this, that this is 0.003 moles of NH3. And of course, if we're at the equivalence point, it would be 0.003 moles of acid that we have added. And of course, the weak base is all consumed, so minus 0.003, minus 0.003. And the conjugate acid NH4 plus is up by 0.003. And that's moles. And in order to use the ICE chart, we're going to need to change that into molarity by using the total volume of the solution. So 0.003 moles. And remember, we started out with 30 milliliters of the ammonia. We've now added 20 milliliters of the strong acid. So 50 milliliters or 0.050 liters. So the molarity is 0.060. Molar solution of NH4 plus. What is the Ka of NH4 plus? Well, I know Ka times Kb equals Kw, right? So Ka will equal the Kw divided by Kb. Kw is 1.00 times 10 to the negative 14. Kb is that 1.8 times 10 to the negative 5. And doing that out, I get 5.5 times 10 to the negative 10. So that's the Ka. So now, what is reacting? It's just the ammonium ion acting as a weak acid, so donating a hydrogen to water to make the hydronium ion and leaving behind that weak base. The ICE chart there, this would be 0.06, 0 and 0, minus x plus x plus x. So 0.06, x and x. The Ka, which we figured was 5.5 times 10 to the negative 10 equals x squared over 0.06. And always remember, when you solve for x, I always double check to be, what am I solving for here? In this case, it's the H3O plus concentration, and that equals 5.77 times 10 to the negative 6, or 5.24 for a pH. And that makes sense because all we have is weak acid, that conjugate acid that's left over after we have consumed all of the weak base. So we would expect that the pH of a weak base strong acid titration is a little bit acidic. So this is now after the equivalence point, which means that we're adding more strong acid than there is a weak base to consume. So we just need to figure out how much strong acid I'm going to have left over, and then its new concentration, and then negative log of that. So what is happening is the ammonia and that strong acid are going to react. They're going to make the ammonium ion, but that is going to be so insignificant. What that is contributing to the pH is so insignificant, we can just disregard it. Right? We know that this is 0.003, but now since it's 20.5 milliliters, right, using molarity equals moles over liters, the molarity, or the number of moles, I should say, of H plus that we're adding is 0.003075. And so when, the smallest amount is the one that gets all used up. And this comes out to be 7.5 times 10 to the negative 5th moles of H plus. This small amount of the ammonium ion is not going to affect the pH significantly. So now molarity equals moles over liters. The moles is 7.5 times 10 to the negative fifth. That's the moles of the H plus. Total volume 30 milliliters plus 20.5 milliliters is 50.5 or 0.0505 liters. The molarity of the H plus is 0.001485. And that is, of course, the molarity of the H plus. So all you need to do is take the negative log of that, and I get a pH of 2.83. And it's kind of crazy that just a half a milliliter more of that strong acid will cause the pH to go from 5 all the way down to 2. But that's what happens right around the equivalence point. Calculation number 6 is 30 milliliters, and it's the same process as was the one that we did before. The pH, the pH or the answer to this problem is 1.60. So I suggest that you try 30 milliliters. It's the same process as 20.5. Try 30 milliliters, see if you can get that answer, and if you have that answer, great. If not, you can watch the rest of this video and actually see how to do it. So we would again actually write out the chemical reaction that is taking place in a BCA chart. And this starts out as 0.003, and now I need to do molarity equals moles over liters again to find the moles of the H plus, and that comes out to be 0.0045. And the ammonia gets all used up, leaving 0.0015 moles of H plus left over. So molarity equals moles over liters, 0.0015 moles. The total volume was 30 milliliters that we started with, plus the 30 milliliters that we're adding, or 60 milliliters, or 0.060 liters. The molarity of that solution is 0.025, and that's the molarity of the H plus. And then, of course, the negative log of that will give a pH of 1.60. So those are the 4 different types of calculations that you will have to do with, what is this? A titration of a weak acid or base with a strong acid or base.